In this video, we are going to do a hypothesis test for independence using the chi-square distribution. The table here at the top shows the observed frequencies of helmet color versus whether or not the person was injured in a motorcycle crash. Over here we have the formula for the chi-square test statistic. And our null hypothesis in a test for independence is always that the row and column variables are independent. So in this case, helmet color and injuries are independent. And our alternate hypothesis is dependence. So helmet color and injuries are dependent. So the first thing we have to do, of course, in order to get our test statistic is to find what our expected values are. And the formula here says we can find the expected value for each cell by taking the row total multiplied by the column total and divided by the grand total. So that means for here, where we have black helmets and not injured, we're going to take the row total, which is 899. We're going to multiply that by the column total, which is 704, and then we're going to divide that by the grand total, which is 1232. We're going to do the same thing for the next cell, so we're going to take the row total for this cell, which is 333, and we're going to multiply that by the column total for this cell, which is 704, and we're going to divide that by the grand total, 1232. Now we're going to do the same thing for white helmets. So white helmets not injured, we have row total times column total divided by grand total. White helmets injured and killed, we're going to take row total times column total divided by grand total. And then we're going to do the same for the yellow/orange helmets. So not injured would be row total times the column total divided by the grand total. And finally here we're going to take this row total times this column total and divide it by the grand total. All right, so we are going to take these expected values and round them, or let Excel round them to the nearest whole number. All right, so those are our expected values. So that's the first step. So in the formula, O are these values in this table. E are the values we just calculated in this table. And now we need to get the O minus E squared divided by E. So this is a little bit easier because I can just do the first one and then copy the cells down. So we have to be sure to put a parenthesis around our numerator before we square it. So we're going to take the observed value, which is 491. We're going to subtract the expected value of 514, close the parenthesis, square it, and then divide by the expected value of 514. And we hit enter. And now we can just drag this down, and then we can take and drag these over. And that gets us the O minus E squared over E for every cell in the table. All right, you can't do that when you're finding the expected values, but you can do that when you're finding the O minus E squared over E. All right, so now remember now that our chi-square test statistic is actually the sum of these things that we just found. So here we'll just type equals sum, and we will highlight all of these. And that's our test statistic. We can find our critical value depending on our level of significance alpha. So if we want a, let's say, a 95% confidence interval, then that gives us an alpha of 0.05. So we would come over here and say equal chi. We would choose chi-square inverse right tail. We are going to put our alpha 0.05. And now remember that the degrees of freedom is the number of columns minus 1 times the number of rows minus 1. So since there are 3 columns and 2 rows, we're going to multiply 2 times 1. So our degrees of freedom is 2. So that gives us our critical value. If we want to calculate a p-value, remember that the p-value is simply the area to the right, because in a chi-square distribution we are always doing a right tail test. So the p-value is always going to be the area to the right of our test statistic. So that means we can just use our chi-square distribution. We want to choose the right tail. We're going to put our test statistic in for x and our degrees of freedom, which was 2, and we get our p-value. Alright, so regardless whether we use the traditional method where we're comparing our test statistic to our critical value, or if we use the p-value method, we're going to get the same result, that we are going to reject H0. And this means that the helmet color and whether or not the person was injured are dependent. Now, this does not mean that there's a cause and effect. That doesn't mean that helmet color causes you to be injured. It just means that there is some sort of relationship between the color of the helmet and whether or not the person was injured.